All right, it's my great honor to welcome you to the special session in honor of Randy Pausch. I'm Brad Myers from Carnegie Mellon University, and it was quite a pleasure and an honor to be invited to help organize this session for my colleague, Randy Pausch. I'm starting with some of his incredible credentials and honors that he's won. He's obviously a professor at Carnegie Mellon University. He's the author or co-author of 5 books and over 70 articles. He started winning prizes even as an undergraduate. He won a prize in computer science from Brown University. His PhD thesis paper based on that won a prize for best paper. As he began his career, he was winning awards. He won the NSF's Presidential Young Investigator Award. And recently, he's been winning an enormous number of awards for all of the incredible contributions he's made in the last few years. He's an ACM Fellow. He won the ACM Karl V Karlstrom Outstanding Educator Award. This past year, he won the ACM SIGCSE Award for Outstanding Contributions to Computer Science Education. He won the Special Award for Professional Contributions from the SIGCHI Executive Committee. Many of us were around in 2005 at CHI when he gave the plenary speech on a technologist's comments on psychologists, artists, designers, and other creatures strange to me. It was a fun talk. Of course, this year he's been put into the CHI Academy, and I recommend that you read the citation for him. I won't read it now. It's too long to bore you with, but lots of fun stuff there. And of course, his last lecture that he gave at CMU in September of last year has been viewed by over 6 million people. How many people here have viewed the lecture either online or in person? So a few of you haven't. I strongly recommend it. The URL is really easy, thelastlecture.com. And that's also the URL for his new book based on that lecture, which is coming out tomorrow. I don't know if Hyperion is here, but it's available on Amazon and all the usual places tomorrow. And since then, since that lecture, he's won a number of awards. He was featured on World News with Charles Gibson as one of the 3 people of the year who have used their gift of speech and music to inspire those around them. That was last year. The last lecture video was actually nominated as one of the 6 most inspirational videos of 2007 on YouTube. And you can still go to this website and see the nominees and the winner. On Wednesday night, there's a 1-hour special about Randy on ABC News with Diane Sawyer, 10 p.m. Eastern. So I'm asking my wife to tape it. I'm sure it'll be online, just like the rest of the videos, if you don't have that available to you. This past Sunday, he was in Parade magazine. If anybody, we were all in the airplanes flying here. So you should check your Sunday newspapers and get that issue. And in honor of his session, his ABC News nightly news session, apparently he's going to be on Good Morning America that same morning, Wednesday morning, and also Thursday morning he's scheduled to be interviewed. I'm told that he will also be featured in next Time magazine, and he has a walk-on part and even a line in the next Star Trek movie, which is coming out next year, so it'll be fun to watch for him in that. So I want to play since most of you have seen the last lecture, I thought it'd be fun to play the promo for the ABC special, and also it gives a good introduction for people who don't know about why we're having a special session at this time. If we could have the sound on the video, please. here. Let's start over.
I am in phenomenally good health right now. In fact, I'm in better shape than most of you. So anybody who wants to cry or pity me can come down and do a few of those, and then you may pity me.
I'm still trying to do one push-up in honor of your lecture. Just one push-up.
It was a lecture that took a university auditorium and then the nation by storm.
We cannot change the cards we are dealt, just how we play the hand.
In September, Randy Pausch, professor of computer science at Carnegie Mellon, gave what he called his final lecture to a packed auditorium.
Make me earn it. My dad always told me when there's an elephant in the room, introduce them. If you look at my CAT scans, there are approximately 10 tumors in my liver, and the doctors told me 3 to 6 months of good health left.
The diagnosis for this 47-year-old happily married father of 3? Pancreatic cancer.
Pancreatic cancer is pretty much the most fatal cancer of all. It is ruthless. It is brutal. Very few people beat it.
Is it fair?
I think it's unlucky. It's unfortunate. But I don't think it's unfair, because I have children and I always tell them that, you know, if we flip a coin and it comes up tails and you called heads, that's not unfair. That's just the way the world works. And we all stand on the dartboard, and you know, a very small percentage of us are going to catch the dart labeled pancreatic cancer.
Really insulates you from the why me, from the anger? Really insulates you from that?
Yeah, I've read all the books, and I'm supposed to be mad, right? And
yeah.
I have never found anger to make a situation better.
In his lecture attended by his wife, Pausch opens his treasure chest of life lessons learned.
Your critics are your ones telling you they still love you and care. Never lose the childlike wonder. It's just too important. It's what drives us. Loyalty is a two-way street. Be good at something, it makes you valuable. You might have to wait a long time, sometimes years, but people will show you their good side. Just keep waiting, no matter how long it takes.
Just a chance that maybe we'll find better days.
If you lead your life the right way, the karma will take care of itself.
He has set out to share and relive his dreams, documenting them with his family. Football with the Pittsburgh Steelers. A trip to Disney World with his family. The moments Pausch knows will one day be his legacy.
I guess the question people keep wondering about is, do you allow yourself times of just curling up and blanket over your head? I'll just go down for the count today for a while. I'll allow myself down for the count.
I can honestly say there's been no day where I sort of locked myself in the bedroom and said I'm not coming out. There is a sadness that comes when I think about my kids. The really strong emotions for me are they won't have me for them. And that's where it's okay for me to say that's not fair.
In the last few months, Randy Pausch has been practicing what he preached, living his life with his family to the fullest.
The metaphor I've used is somebody's going to push my family off a cliff pretty soon, and I won't be there to catch them, and that breaks my heart. But I have some time to sew some nets to cushion the fall, so I can curl up in a ball and cry, or I can get to work on the nets.
A very special Diane Sawyer hour, the last lecture.
So everybody always asks how he's doing right now, and he's doing a pretty good job of keeping his blog up to date. There's an entry from last week, and he's doing better than expected. He, in September was given 3 to 6 months. It's obviously been longer than that already. He had heart and kidney failure from the chemotherapy a few weeks ago. So he's off the chemotherapy, but his cancers aren't growing quickly, which is a good sign. So he sums up his last entry with, "The fight is rejoined. I've got much more energy now. I hope to be back on the bike in a week or so." If you don't know the story, he wrote the last lecture book by dictating most of it to his co-author, Jeff Zaslow, while he was riding his bicycle around and keeping up the exercise. So what are we going to do today? Well, we thought it was most appropriate for the CHI audience to give a summary of all the incredible contributions that he and his lab and his students have made. And so we're going to give you just a briefest overview of the contributions by having his students and come up and talk about the work of the various eras of his life. So Matt Conway is going to represent some of his earliest work while he was at UVA. Jeff Pierce will talk about the virtual reality work. We were very excited that Don Marinelli had agreed to come just for one day to CHI to present his work on the Entertainment Technology Center, but then US Airways messed up his connections and he got stuck in someplace in the United States, I forget, some random city, and in fact ended up going back home because he couldn't get here in time. So unfortunately, we weren't able to have Don present with his incredible energy, and Dennis is going to fill in on that part. And then Caitlin will talk about his most current work on the ALICE system, and then Dennis will sum up with some really interesting observations about how Randy has collected people together and really gotten all of these people to work well together. Finally, I hope there'll be some time for you to present messages as well. We are taping this session and we'll be sending a copy to Randy as soon as we can. So if there's anything you'd like to tell the audience and Randy, then we'll be delighted to take that afterwards. So Matt?
Thanks very much, Brad. Is that mic on? Good. And we're not getting video. Huh? There we go. Good. Great. Thanks very much. So I'm going to talk for a few minutes about the very earliest works that in Randy's group. I was with Randy from pretty much the very beginning. I think I missed the first 6 months of his career at the University of Virginia. The very first project that he had me work on was a thing called SUIT, the Simple User Interface Toolkit. Most everybody remembers Randy for, I think, the 3D graphics and the virtual reality work and the stuff that came out to ALICE. What's not remembered very much these days, though, is the very earliest work, and a lot of the lessons learned in SUIT became very important for us later. And so one way of characterizing the work of SUIT is as a prehistory of ALICE. So I want to look a little bit at the timeline, and if you march from today backwards in time, from ALICE and all the various flavors of ALICE, even back to the early VR and $5 a day, which Jeff and Caitlin will be talking about later, what you'll find is right about here is where SUIT happened, and the arrow here is meant to denote that some of the things that we picked up in SUIT ended up impacting the very first virtual reality systems of ALICE. So what was SUIT? SUIT was a user interface toolkit. It was a collection of widgets, user interface componentry like menus and buttons and sliders and radio buttons, and the runtime necessary for supporting them. And the one research contribution that we were trying to achieve with SUIT was making something that was really easy to use, and we kept a very hard line on this: make it a 10-page tutorial that you could learn in 45 minutes or so.
So he says the AV isn't working.
The AV is not
working.
working.
Can you switch to lower resolution?
Lower resolution.
Because we go in
Frequency
1024.
This is 1024 by 768.
And the frequency should be less
the
than.
refresh rate.
Hang on. Sorry, guys. Sorry.
Don't mind.
It should be in the displays preference pane.
Definitely.
Okay. $60 hertz?
No, go way up to.
60.
Oh.
60 is okay, right?
Go way
Can
up.
we have a smaller resolution then?
And 60
Keep
is the
going.
minimum.
No, no more. Go up.
Yeah. Nice.
1024.
You want more like that?
Yeah, that'll be much better.
Okay, with the screen is okay.
Okay.
Thanks.
Okay, good.
Yeah.
Sorry about
Thanks.
that. Let's hope the... Better? Okay. Okay. So Suit's primary goal was to be something that was easy to learn, and we held that with by saying a 10-page tutorial that you could learn in under an hour. It had a bunch of other interesting properties, which I won't go into. They're fairly technical. But I think the easiest way to sort of show off what we were trying to do is to give you a demo. And this is Suit. And this is the demonstration program that we packaged up with Suit that was sort of a display cavalcade of all the widgets that we had. I think it's important to remind you here, what you're looking at is software that was written in 1989 to 1992. This program was probably last compiled in 92 and probably has not been given a demonstration in public for 15 years. So the fact that it runs at all is a slight miracle. And there's an animation system in Suit. Somebody. And one of the other remarkable things is at runtime, this program here, actually, you could inspect any of the widgets. So for example, there's radio buttons, and here's a menu widget, and this is a text editor that supports Emacs key bindings. And I could go over to any widget and say, show me your properties. And the runtime system would bring up a property sheet. And so here's the properties for this object, and you can see its foreground color was red, and it has 7 sides. And then there's properties for the polygon for the class of widgets it is, and then there are global properties. And any of them could be sort of edited on the fly. You could say, no, I want the polygon to be that color instead, and you would get that. So let's just go back to the talk. The S in Suit actually stands for simple, and that's important. Pedagogy was our #1 goal. We called it the Pascal of user interface toolkits. To sort of stage it as a teaching tool. And one of our goals was to get non-user interface professors the ability to give out homework that had a user interface component to it. So if you were a database professor, you could tell your students, I want you to write this interesting database program, and it has to use menus and use menus and use buttons to kind of express the answer to the homework. This is a completely unachievable thing back in the late 80s and early 90s, because to ask a professor to give up so much time to just teach the user interface part would have taken away from all the interesting database parts. So it's really important to kind of go back to 1990 and remember what things were like. And you might think of your browser as being something like this, but the answer is really not yet. We wouldn't even have Mosaic for another 2 years. And all the interesting user interface work was still happening on the desktop. And there was no Visual Basic when we started this work. VB 1.0 came out while we were progressing on the second version of Suit. And even if we had Visual Basic, it doesn't solve the problem at hand because it's Windows only, and it wouldn't be free. It would be economically infeasible to give Visual Basic to all the students of most universities. So I know a lot of people are saying, yeah, it was uphill in the snow both ways, and this is from way, way back. How hard could it possibly be? And the answer is, to build some of these things really was exceedingly difficult. And let me give you a sense of how hard that was. The point I'm trying to make, it was almost too hard to teach on top of any other program, any other programming sort of topic. These 4 books represent 4 of the core manuals for the X Window system, which was sort of the other windowing system and gadget system at the time. And if you wanted to actually crack this, these 4 books alone is over 3,600 pages. And maybe a better measure of that, it's over almost 12 and a half pounds worth of documentation. Now there's probably 100 pages or maybe 50 pages in here that you really need to get something up off the ground, but it's buried in a pile 3,600 pages deep, and you'd have to go find that stuff, for those of you into metric. Right? The more important point is to drive through all of that stuff. The conservative estimate was maybe 6 to 8 months of professional activity would get you up to speed and make you feel conversant in the X windowing system. And that was sort of the baseline to beat at the time. 6 to 8 months of talented programmer. We wanted to bring that down to maybe an hour with somewhere between 0 and 1 years of computer programming experience. So to show you that I'm not lying, what you're looking at the screen right now is the Hello World program for X Windows. Actually, that's a lie. This is not Hello World. This is the first page of Hello World. That's the second page of Hello World, and the third page, and the fourth page. And we thought we could do a little bit better. And we asked ourselves, what if we could collapse that to something more reasonable? Take all of that pages of stuff there that actually asked people to give explicit control over their windowing system and made them defaults, reasonable defaults for a system. How short could you make a Hello World program? And this ended up being the answer. This is Hello World in Suit. And I'm going to highlight the 3 lines that are actually Suit, which is start Suit, make a button, and start the application. The other 2 lines are just C, and you have to do that because that's what you get for the language. And so that gives you an idea of where we moved the bar with this system. And we were very proud of the ability to collapse most system programming to just the expressions that you really needed for your UI. There's usually 1 line of code for the gadget, and all the other lines of code were for the application logic, which is sort of where you wanted the bar anyway, especially if you were that database professor. So I'm going to talk a little bit now about how we arrived at a system that was so simple. And these lessons were not so important for the Suit stuff as it was for the lessons we learned that we dragged forward year after year into the Alice system. And you'll see these themes being played over and over again as these other speakers talk about the Alice stuff. So our first design approach was to write the tutorial first, 10 pages. And we wrote that thing over and over and over again. There were dozens, literally dozens of iterations of these 10 pages. And our rule was if you can't explain the idea in the 10-page tutorial, the idea is too complex. And you have really three choices. You either fix the thing in the system that's being too hard to explain, you demote the importance of the system so you don't have to teach it in the tutorial, it doesn't have to be part of your first out-of-box experience is what people would call it later, or you remove the system feature entirely so you don't, the simplest thing to document is the thing that doesn't exist, right? So you just hack the idea out of the system in the first place. And that worked really well. This, again, is foreshadowing for Alice. I won't go into much detail, but when we came to do a tutorial for Alice, that thing, the dictate wasn't 10 pages, but we wanted something that you could do in about an hour, and we wanted it to fit the tutorial physically inside a jewel case of a CD. Another lesson we learned, of course, was the value of testing. And we came to the same idea that a lot of people have, that APIs are user interfaces too. And if you want real expressive power, you should treat those APIs like the user interfaces they are, and you should test them. You don't just write them and design them and throw them over the wall. You subject them to the same kind of Darwinian forces as any other user interface. And that meant both the testing of the tutorial and of the code or the system, the IDE that you would have. And we observed hundreds and hundreds of people working through Suit, and we used that data to drive the design of Suit. It was also important that developers be part of that testing. It was important to sensitize the developers to the problems and make them feel the pain that these customers and these users were going through. We sat behind them in a kind of a 2-person talk aloud protocol that Chi people are very familiar with. And of course, it was very important not to let people fail, and not interfere. And this is sort of what it looked like. This is a very staged photograph, but it was one developer sitting behind 2 people talking to each other about Suit. And going through the tutorial and taking notes. It was really important to keep your butt planted in that chair, and Randy had a thing that we were allowed to say, if we had to get up out of the chair to help somebody who was stuck in Suit, he had something rather tongue-in-cheek that he had us say, "I am sorry for building crappy software. Here, please let me help you overcome it." If you have to say that before you help your user, then you keep your butt planted, and you never know what you might hear. And it was a very, very healthy discipline to kind of keep us on track. Another thing we learned is to be real. So we released Suit to the public. We released it often. And we had a Usenet news group. Again, this was before the web. Our distribution model was FTP. It was barbaric and painful in comparison to the things we had to do today. But we took the pain and we pushed those bits out the door because we wanted it to be in the hands of real people solving problems. We wanted to teach, Randy used it to teach classes and got his colleagues to teach classes with it too. Another rule, give the stuff away. Suit was free to nonprofits, just like Alice would become years later. Free to educational organizations, but if you were a for-profit company, you had to pay for suit. The pain, though, of having to deal with college lawyers, university lawyers, was so high that Randy said, you know what, if we're going to make this for pay, I don't want it to be a $500 thing. I want it to be so expensive that nobody in his right mind would touch this thing. It's got to be worth our while. So to give you a comparison, well, what would that price tag be? At the time, there was a cross-platform industry-hardened piece of software called Galaxy. It was a user interface toolkit, much like Suit, but much more powerful in many ways, and it was selling on the open market for $5,000. So what do you, if the professional stuff is $5,000, what do you charge for the student-supported, which is to say not supported piece of software? There's no 800 number you can call, and the stuff is probably under development and still buggy. Well, naturally, you charge $25,000 for that piece of software. We thought nobody would take that and we would be out of the woods. We failed at that mission. GM bought one license. They were the only one who bought a license, but please don't worry, it's not in your car, okay? The Suit software was used by the research and development program for prototyping little interfaces and controlling other kinds of programs. We were very clear on that we didn't want to have cars running Suit because we knew how stable Suit actually was. So, but something interesting happens when you get one check for $25,000. It's not an enormous amount of money. It's not nearly enough money to even support, well, you could probably support one grad student for 1 year at that time, but that's it. The question is, what do you do with a windfall after the government takes half of that? You've got $12,000, $13,000 to do something with. And Randy's decision was really, really interesting. He could have taken that money for himself. That would have been perfectly within his purview to do, because that money was treated by the university like a textbook sale. You write a textbook, you enjoy the profits of the sales of that textbook. But Randy said, you know, you guys worked really hard to put this Suit thing together. The money should be used for the support of the group. And we're going to use it to make a culture of fun. And so we spent it on pizza and meals and furniture and stuffed animals and toys for the lab and things that made a really great working environment. And there's one other thing that we use the Suit money for. And everybody, a lot of people who know Randy know this, but when Randy got tenure, he took the entire research group, and including people who had already graduated, and called them back and said, I'm taking you all to Disneyland. And it was remarkable. It was just a remarkable few days. And it was a great way to thank the crowd for helping out in his attaining tenure. And of course, we owed Randy a great debt for that as well. It's one of my warmer memories of Randy. Again, a thing that he didn't need to do, but if you knew Randy, you know that it was absolutely inevitable that he would do something like that. So some points in closing. The lessons we learned from Suit that we carried forward into the Alice stuff. Be simple. Also be ruthless about being simple. Your system doesn't need the features you think it does. If you want to have systems that are as simple as Suit was, re-examine every assumption you have about whether things actually need to be in there. There were very beloved features we had in Suit that we hacked out, and the system collapsed in both size and complexity, and the tutorial got shortened by 20%. Observe your users, especially have your developers observe your users. There's nothing like sensitizing them to the pain that your users are going through. Release real software to the real world. And the final lesson that I think you'll see as a theme that runs this consistent arc through Randy's research program is the democratization of technology. There's something magical and something powerful that happens when you can lower the bar to entry to really hard technology so that everybody can use it. We did it for 2D and graphical user interfaces. We did it with 3D in the Alice projects when those things came up in actually really remarkable and magical effects. I'd like to roll some credits. These are the people responsible for Suit over the years. Nat Young got his degree off of it. The guys in yellow all helped. And Randy, of course, is the PI. And I guess the next chapter of this is with Jeff Pierce, and we're going to talk about some of these themes rolling forward into the world of VR. So thanks. It's all you.
Okay, quick laptop transition here. So when Caitlin and Brad emailed me and asked me to talk about VR, I said, okay. And they said, well, we want you to cover sort of the highlights of 16 years of research, and you have about 12 minutes. So this is going to sort of be a subset of the highlights. There's obviously much more that I could have talked about. Hang on, the laptop is thinking. Okay, I'll just do it this way. Like that better. Okay, so when I was trying to think about sort of how to organize the collection of work that Randy had done in VR, I started thinking about the name that the group had when it was at Carnegie Mellon. So Randy actually started as a faculty member at the University of Virginia, and then around 98 or so, moved the group up to Carnegie Mellon. And previously at UVA, the group had been called the User Interface Research Group because there was no one else there doing HCI. But obviously at CMU, there's a lot of groups doing HCI, and so we can no longer call ourselves the User Interface Research Group. No, that's something really arrogant. We were the group. And the name the group came up with was Stage 3, and the question we got all the time was, why the heck are you guys called Stage 3? And it actually goes back to a formalization that Matt Conway came up with, looking at sort of the 3 stages that new media go through. So thinking about virtual reality as a new medium, and drawing analogies with other media like film. The first stage is where you sort of do anything, and it's perceived to be new and interesting just because the medium is so new. So there's the famous film Fred Out Sneezing, which, for its time was one of the first films and was regarded as sort of this amazing new thing. Stage 2, once you get past that, is you sort of start emulating existing media. And so you film stage plays, you film the real world around you, but you're just sort of emulating what's gone before, not doing anything new. And then stage 3 is sort of where all hell breaks loose. We start trying to figure out what's sort of new and unique about that medium that you can do things that haven't been done before. So crosscut, flashback, fade are all sort of part of the things that film brought into our lexicon. And one of the things that Randy really stressed was, what is the lexicon for virtual reality? What is stage 3? And so I'm going to sort of use the framing mechanism of breaking assumptions to talk about some of the work that Randy did. So one of the first assumptions was virtual reality is expensive. So back in 1991, if you wanted to do virtual reality and you wanted a high frame rate, you went out and you spent $500,000 on a Silicon Graphics reality engine workstation. Okay, so there's a very high barrier to entry. And so sort of hitting the theme of lowering the barriers to entry for different fields, Randy's first real prominent Chi paper was some research trying to figure out how to make the barrier to entering VR a lot lower. So the referred to as VR on $5 a day. The cost is actually amortized over, what was it, 3 years, 5 years? 3 years. So, 1825 times 3. But still, for its time, that is several orders of magnitude lower than what you would have spent on a Silicon Graphics workstation. One of the other common assumptions at the time was sort of that virtual reality was lunatic fringe. Nobody doing real science, real research does virtual reality. That's only the nutcases and the kooks. But Randy actually did a number of things to sort of challenge that assumption. He formed a collaboration with Denny Proffitt, who's a perceptual psychologist at the University of Virginia. And they proceeded to do a variety of research explorations, both from the computer science side, trying to establish what was unique about virtual reality, what benefits did it bring over desktop computing, but also from the perceptual psychology side. How could you actually use VR to learn more about the human perceptual system? So you could actually do real science inside of virtual reality. And also looking at real-world tasks. So Ken Hinckley actually got his PhD looking at props-based interfaces. And one of the tasks they were looking at was, how do you allow neurosurgeons, people who do not like to look like idiots and so want systems they can just walk up and use, interact with MRI data so they can do things like plan surgery paths when they want to operate on someone's brain. Of course, once you show that you can do real science and research inside of virtual reality, some people go the other side and say, well, we've spent millions of dollars on this equipment. VR is serious stuff. It should be used for real, serious research. And those of you who know Randy well know that he was actually a firm believer in this. He actually worked really hard to turn his laboratories into sort of temples of knowledge where we all wore white lab coats and thought deep thoughts. And we worked hard to sort of build the latest and greatest in scientific research tools, made sure we always had cutting edge stuff. Great picture of Dennis there, by the way. He worked on sort of advanced vehicle simulation, his sabbatical with Disney, looking at next generation vehicles, what we might use beyond the car. We had funding from DARPA actually to do Alice, so we had our military training simulation. By the way, that's the Space Light Sword game, not the Star Wars game. Don't look too closely. Early social networking research, the Mad Hatter's Tea Party at SIGGRAPH, early uses of collaborative virtual reality. I couldn't come up with a rigorous scientific explanation for a man wearing a Spider-Man suit, but work on building virtual worlds and sort of extending this to the masses so other people could sort of build experiences as well. Okay. Where a lot of the sort of research publications came from was trying to get beyond one of the assumptions that in many ways still prevails, which was virtual reality should be used to emulate the real world. It's just like being there. You can put on a head-mounted display and it's just like you're visiting the Sistine Chapel or you're visiting ancient Rome. But one of the observations that was made inside the group is that, we're working in a new medium here, we're trying to think about stage 3, what can you do here that is different than the real world? So probably one of the earliest and still most cited interaction techniques the group came up with is some work that Rich Stokely did on the worlds in miniature. And the observation that he made is that there's no reason you have to have just a single copy of objects in the world. We're doing virtual reality. We can create as many copies as we want. Computers are good at copying things. So why not give people a handheld version of the world that they're in so they can work with a miniature object and actually affect the objects at a distance? There was sort of this theme in virtual reality of how do you allow interaction at a distance so that people don't have to go all the way over to an object, pick it up, and then move someplace else and drop it off. With the world in miniature, you could act within your hands and control objects that were too far away to physically reach. They came up with another really nice trick they could play here, break another assumption. One of the observations that was made about the WIM was that although they allowed people to navigate, it was actually somewhat disconcerting. The way you navigated with the original WIM was you grabbed at the little object that represented yourself and you dropped it off. And then the system would actually animate you in the virtual world to that new position. But it was somewhat jarring. You could pass through walls. People would suddenly, if you're holding the model in a different direction, you'd suddenly be moving in a direction you didn't expect. And because people were already vested in that model, they made the observation that why not instead fly people down into that model? And then the model actually became the world that you were in, and you had a new WIM that appeared in your hands. So playing some nice tricks with perception there. Something that looks like it is real suddenly becomes real in that virtual world. And we actually played that trick a couple more times as well. Randy also encourages students to draw heavily from the classics. So this is a snapshot from Kids in the Hall, for those of you young enough to remember. There was a sketch in Kids in the Hall with a character who would go around and he'd crush people's heads by framing them between his fingers and pretending to squish them. Well, obviously, there's sort of some perceptual illusion going on here. But in a virtual world, we can actually break that illusion and turn that into reality so that I can frame an object between my fingers and I can actually pull it away in the virtual world. I can create a copy of it on the fly. And I can manipulate it and inspect it and all sorts of fun stuff. And then we could sort of go back to the WIM with this idea in our back pocket now and have this notion of sort of creating copies of objects on the fly. But now instead of this permanent WIM, you have sort of this transient nature, and it allows you to work at different scales. You can grab a small object and work at a small scale, or grab a larger object and work at a larger scale within that. Okay, one of the last assumptions I want to quickly mention is Randy did a sabbatical at Disney Imagineering, actually the first year that I was in his group. And he came back all fired up because he had seen the future. For a long time, when you came to a virtual reality lab, you put on the head-mounted display and you were still standing in the lab because the researchers had built a virtual version of their lab. So, great, you got to experience their lab, only it was lower fidelity and there was latency. When Randy was at Disney, he had actually worked with teams of engineers and artists. And what Randy realized is that when you add artists to the mix, you can do so many more things to make these experiences more interesting to their users. So quick example, one of the standard demos we gave was the Star Wars lightsaber game. The image on the left is the one that the engineers had come up with, and the image on the right is after we had incorporated some artists into the group. So if you were a user coming in to do the Star Wars lightsaber game, which one would you rather do? And Dennis will talk more about sort of the more interesting things that we could do once we had actually combined the group to be both artists and engineers. This is actually a complete aside. It has something to do with the virtual reality. But one of the things I wanted to say is that in the 6 or so years that I spent working with Randy, I learned a lot of things. But what I really admire most about Randy is his ability to pick good people. We used to say that to get into the group, you sort of had to be smart enough, talented enough to sort of be above threshold, but that wasn't enough. Randy really worked hard to select for, works and plays well with others. And of all the people that I've sort of worked with in my research career, I think Randy did the best job of assembling the best bunch of people. There's still folks that I admire greatly, and I still have great relationships with all of them. And with that, I will turn it over to Dennis.
He knows him, but he's this monumentally gregarious and exciting person. And sadly, he couldn't be here, but I'm going to give a talk that leads into some of the things about his relationship with Randy and building the Entertainment Technology Center. So for those of you who know Randy or have seen the last lecture, you know that Randy has this childhood dream. This is actually Randy at Disney World, and one of his childhood dreams was to be an Imagineer. And one of the nice things of doing all the really high quality VR research, especially the collaboration with Denny Profit and the interaction techniques that Jeff was describing, is that it really made Randy this bigwig in computer science. He was actually doing science in VR. And he was able to roll this into being able to work at Imagineering, where they were building the top of the line experience in VR. And as Jeff was describing, what Randy was trying to do with his research group was to find the new interaction techniques for VR. And what Disney was doing is they were trying to use this new medium for storytelling. And I'm going to give you a quick flavor of what the Aladdin attraction was like. And a lot of this is, this has audio, by the way, which I will pause for a second because it's not plugged in. Okay, and this is just to give you a little feel for what it was like to actually be in VR. I think VR has been this fad that has come and gone, so a lot of people might not know exactly what we're talking about. But you put this head-mounted display on your head, and as you turn, the world updates, so it's as if you're there. And so, unlike what we were doing, which was to develop new interaction techniques for this, they were taking people to this new space and using it to tell stories. And this is, you gotta remember, this is from the early 90s. And computer graphics is not something where things stand the test of time, but they actually built something that you can go to right now and is still this very compelling experience.
Incorporating breakthrough techniques.
Okay, I'll move on from that. And one of the nice things was that Disney was, really trying to learn from this whole thing. And so they ran 1 million people through watching this, and 45,000 people ran through and did this VR attraction or the many iterations of it, and they gathered all this data about where people looked and everything like that. And for those of you who write papers for things like Kai, imagine someone asks you what's your N and you can say 45,000. It's like one of the really nice things. And they were able to write this paper, and it was very well received, and it was very exciting to find out all this information about VR, especially from Disney, which is a very kind of internally doesn't really share information. And Randy was able to roll this experience into being able to continue his work with Disney and do consulting on other Disney Quest attractions like the Virtual Jungle Cruise and Pirates of the Caribbean, which is actually a phenomenal experience. It's actually worth the trip to Orlando just to do that one ride. And so it was all very, I would say, fulfilling, and it was, it was like sort of achieving a childhood dream. But what the real impactful thing, I think, was what Jeff was referring to, in that he got to go there and to really experience and see the magic that can happen when you put artists and engineers together. And the driving force behind this was John Snoddy, and he just sort of fundamentally believed that you can't just have artists and engineers working in parallel, right? You can't have the creative department and the engineering department and they're working on a project. Because as he says, who wants to work with an uncreative engineer? It's not enough just to have really highly talented people. You've got to have them working side by side, and that's where the real magic comes out, and that's where you can make a one-of-a-kind experience. The other thing that John Snoddy said, and Don said, and everyone says, is that it's not easy. You can't just decide, I'm going to put artists and engineers together and magic will happen. You really need this driving force. It's kind of like mixing up oil and vinegar. You need a driving force to keep shaking the people up, right? You have to keep them working together, otherwise they'll separate out into their own tribes. And so Randy left to do this sabbatical after sort of the tenure push and received tenure and went off, and you could, as you might imagine, kind of drained by that whole experience. I cannot describe to you how excited he came back, right? He was just like, he had a bee in his bonnet. It was like, this is going to be it. We're going to bring artists into the group, and it's going to be awesome. And so he started to do that. And this, I'm going to show you a quick demo. And I like this demo because it's the sort of thing where all the adults in the lab, if you will, the graduate students and Randy, and we all went off to a conference. And we left this team of undergraduates, these 6 students. And in 10 days, they built this thing from scratch. And we were just blown away by this. I mean, this was way back in the early 90s, and Randy had just come back from Imagineering, where they had these whole teams of professional engineers and artists working together on this thing. And just these 6 students were able to build, to model, paint, and animate this world. And what was even more amazing is that they were trying to get these particular things. Everyone paused when they came to the spikes room. And they were all excited because they had actually gotten their effect that they were searching for. And so this goes on for a long time. I'll sort of cut it short. But it really provided the motivation. You're like, okay, we can do this. Let's do it on a grander scale. And so one of the first things Randy did when he moved to Carnegie Mellon was start this Building Virtual Worlds class. And I had the distinct honor and privilege. It was a fantastic class. I got to be one of the first students and a TA in the class. And going into it, I had this really healthy amount of respect for working with for artists. I mean, I'd worked with them in the lab. But just the format of this class of being thrown into a group with artists you don't know and said, you have 2 weeks, build a whole virtual reality experience. And just how hard everyone worked and how everyone sort of came together to bring these things to fruition. It was just kind of this amazing experience. And I think it was very well engineered by Randy. He was actually going for these very specific things, and they worked out. The other thing that sort of happened, and for those of you who've seen the last lecture, Randy referred to this, but it became this sort of cultural phenomenon at CMU, and we ended up putting the show on at the end of the year. They do it every year. And so people would line up to come see it. And when I just tell this and I sort of let it go, people stop me and say, like, you have to really kind of think about that for a second. Like, people are lining up to go watch people turn in their homework. And just how amazing this class was. I'm going to give you a flair of one of the first worlds from the class. Let me go back here. And this was the Spider-Man world that Jeff showed an image of before. And you'd put on the head mount, and you look around, and you could crawl. We instrumented your hands with gloves, and you could crawl around and sling webs. And this whole world was built in 2 weeks, right? You get put together with, you put 5 people together, some artists, some engineers. You say, build this whole thing from start to finish. And the nice thing about this world was you could put anybody into it, and they would enjoy it for a couple of minutes, right? They would actually crawl around and go, oh, that's nice, and then they'd come out. You could put like a 12-year-old boy in this forever, and they would never ever want to come out. So it's kind of interesting user feedback there. The other thing that happened in this class that I certainly didn't anticipate was people started doing computer science as a performing art. Certainly I didn't think about this at all. My whole thing was that, we'll focus on what the user's experiencing. But a lot of people started worrying about what the audience and how people perceived them on stage. And this is one of the things that Don really reacted to, is that computer science was turned into this performing art. He was sort of taken aback and to some degree shocked by, here's this computer scientist that's reaching out to drama in the arts department. And I think that's something that we can leverage off of it, that people sort of expect us to be these introverted nerds. And you can surprise people by reaching out to the arts and everything like that. And so he and Don were put together to build the Entertainment Technology Center. And that's essentially just more of the same, right? It's a professional master's degree program where they just do building virtual worlds on steroids, right? They just keep putting artists and engineers together, and everything about it is just to keep that active. They're just constantly doing projects. I think that's actually one of the things that I didn't realize at the time, but part of why we had 5 projects is that we're just constantly being shook up, right? That you don't have time to slow down, so you can't separate right out into your tribes. And sort of the proof is in the pudding, if you will, as far as how it's successful. Don was actually telling me that I think 6 or 7 of their students just from last year went off to Imagineering, so sort of this very successful program. It's sort of referred to as the gold standard for training people. And with that, I will hand it off to Caitlin, who's going to talk about the ALICE system.
there we go. So Alice is a tool that helped a lot of these kinds of things to happen, and it has a little bit of a chameleon property. So it has changed purposes about at least 5 different times over the course of the history, starting in the early 90s and still continuing today. And the real beginning of this was coming out of the interest that came out of the VR on $5 a day. So when Randy published this paper, he was then invited to go off to a whole bunch of different universities and give talks about the VR project. And so he'd go out to dinner, and then he would sneak back to the labs where he was talking to other VR researchers and their students, and go in after hours and ask the graduate students, okay, well, what is it that's really hard about this? What are the problems that we really need to be solving? And the feedback that came back from a lot of the students was, well, I hoped you liked the demo because it's all we have. And it turned out that a lot of these people were spending months and sometimes even years developing fairly basic VR demos. And so that became the impetus for the first Alice system, which was really targeted at rapid prototyping for virtual reality. And the real deal here was that in the early 90s, the computation time was still ridiculously expensive. And so just loading the models and the textures and getting your system up so that you could see it do anything was often a prospect that took several minutes. And so the typical process of, I'm going to have my wireless do something interesting. Resume. All right. So the typical iteration of I'm going to make a minor change and run it again could have you just spending all of your time waiting for the system to come back up. And so what the early Alice system did was actually to separate out the graphics engine and the simulation engine so that you could load the models once and then just concentrate on what is the logic and what is the interaction behind this. And so rather than taking the factor of I'm going to make it load twice as fast, it's going to say I'm just going to make this thing load once and we'll use it forever. And if that thing takes 5 minutes, so be it. And so this was off and running and doing fairly well, and the lab, which was at UVA at the time, had a visitor from DARPA who came in and looked at all the demos and said, yeah, okay, cool. But I don't really care that much about virtual reality. However, I do care a lot about 3D graphics, and if you unplug the head mount you have here, you actually have a system that would be fabulous for 3D graphics programming. And so this brings us into the second chapter, which is 3D graphics for the masses. And I think the obvious next step here would have just been to say, we're going to make 3D graphics accessible to people who have some kind of a programming background. And I think it is one of the other places that Randy really said, we need to push further on this. We need to actually make it so that we're going to really lower some barrier here. And so the goal was not, we're going to make this accessible to programmers, but actually to non-technical users. And the gold standard on that was the 19-year-old English major. So there are a number of pieces to this. One of them was the early system was running on an SGI machine and a Sun workstation, which obviously isn't feasible for most people. And so there was an engineering effort to make it run on consumer PCs. As Matt talked about with Suit, there was a very strong focus on user testing the API. And this comes out in a number of ways, and I'm just going to scratch the surface here. But 3D graphics has this very standard set of constructs that is used to do basic motions. So translate, rotate, and scale. And if you talk to just some random person off the street, what you'll find out is that translate is about Italian to English. And rotate, well, it's a word that we use sometimes, and people kind of know what it means, but it's not one that appears in vocabularies too often. And scale is about how much something weighs. But we do have words for these things, and if you just demonstrate the motion, what you'll find out is that people use move, turn, and resize. And there's no reason that we shouldn't be using these words. Similar, X, Y, Z, we all have a concept of where our coordinates are in the world, but we don't call them X, Y, and Z. And so these things are all, taken in isolation, very small pieces, but what they do is they add up to a general loss of frustration. So I don't know who to attribute this statement to, but I think it summarizes the philosophy behind it. So Alice really avoids the death of 1,000 cuts. And again, there was this focus on really designing the system around the tutorial. And the tutorial and system were both in development at the same time. This is actually a picture of the cover of the jewel case that Matt was describing earlier. And when you make it so that all of your tutorial items really have to fit on this single, very small, 4x4 kind of a page, you can't make it too complicated. And so that force really just creates an ethos of thinking about the user throughout the process. So the beginning of the next stage, there are actually two factors that drove us into the next part of the Alice's history. And the first of which was Randy took a long car trip to Disneyland with his nephew, Chris. And this is Chris. And during the time, as many adults do, he tried to entertain Chris by, showing him Alice and trying to get him to build stuff. And Chris had no problem understanding the model, and he was able to sort of describe what he wanted to have happen, but he just kept hitting his head against syntax over and over and over and forgetting parentheses and not capitalizing something that should have been capitalized. And it was really just a very eye-opening experience and actually meshed well with some user test data that we had as well. But the process of seeing that and seeing his nephew struggling so hard was very eye-opening for Randy. The second piece that happened was that Randy was approached by two educators, Wanda Dan and Steve Cooper. Wanda is now at Carnegie Mellon. And Wanda had actually gone to the CHI conference in 1998 and seen a demo of Alice there. And she'd seen it and said, oh my goodness, I could use this to teach computer science. And so she'd gone back and talked with Steve, and they had started to actually build a course around using Alice 98, I think at the time, to teach computer science to beginning students who were coming in. And so they came and they propped down this big stack of materials and said, look, you really ought to think about using this tool as a way to introduce people to programming. And so that, in combination with Chris and his struggles with syntax, moved us into the space of trying to make Alice as a gentler introduction to computer programming in general. I think to Randy's credit, he's always been good at recognizing when other people have good ideas and not trying to reinvent the wheel. And one of the systems that was already out there was a system called Squeak that was built by Alan Kay's group and has a drag and drop based interface where programming commands are represented by all these little tiles, and you can assemble them to make these very basic programs. But it has a fairly low ceiling, so a lot of things that you would want to teach in CS 101, for example, aren't really possible. But the goal was to sort of take that style of interaction and to get rid of the low ceiling phenomenon and make it so that it could actually get across all the concepts that we want people to learn in their first course. And again, following up on the tutorials of the previous systems, in this case, it was develop the system in combination with the textbook, which I'm sure frustrated the heck out of the textbook authors at some points because the system was constantly changing under their feet. But anytime they came back with, it was really hard to explain this to my students, that was a clue that we needed to change something about the system. So this is just a very, very basic screenshot of pieces of the system, but it gives a hint of the interaction, and there's going to be a demo coming up of the next system at the end. But what we have here is the 3D scenes. We have the chicken in it, and you construct programs by dragging these tiles and selecting all the parameters. And it does have all of the things that you would normally expect. So we can do if statements and methods and parameters and all of those good things. And there have been some formal studies done showing that if you introduce Alice to at-risk students, you can actually increase both their grades in a later Java course and their retention in computer science. This is actually a student in a summer program who just really summed up the sort of ethos behind this very nicely, and is one of Randy's favorite quotes. So Randy was really excited about the drag and drop interface, and we had it up and it was stumbling, and we had shown it to a bunch of people and it was being used in some contexts, and he came into a meeting that I had with him one day and he was like, this is so easy, even the girls will like it. And I sort of remember kind of slowing down a little bit and thinking about it and then coming back with, well, why would this be fun? And so that sort of pulled us into the next piece, which was to try and make programming a means to an end that kids, and particularly girls, would find compelling. And so we chose storytelling as the route that we were going. The data on female students in computer science is abysmal. We are now back down to where we were in about 1973. And it hasn't changed much over the last couple of years. And the reality of the situation is that if you don't get kids before the end of middle school, they often opt out of math and science and become very, very hard to get back. And so the core for the system really became, we're going to figure out how to get middle school girls to engage with this. And so I started off by doing this by, bringing Alice 2 at that point into, classrooms with lots and lots of middle school girls and just trying to get reactions. This was from a session with 3 12-year-old girls. They were in 7th grade. They came in, they did the tutorial, they had no problems with it. And one of them finished and she looked at me and she's like, okay, well, I can do this, but why would I want to? It's dumb. And she had no interest in continuing. And sadly, as we did more and more user tests, this just came up over and over and over again. And so what we did was to go really hard after storytelling. And so there are a number of pieces that were important in that process. One was to really make sure that we were able to capture what users want to do. And the subtlety here is that if you give people a system and you ask them for comments on that system, everything is based on their model of what they think the system is capable of. And so to really get at the kinds of stories that kids wanted to be able to build, we had to ask them to design the stories in some other context. So we actually used storyboarding for that. And one of the things that came out of this was it's really all about the people. Alice 2 and some of the earlier systems had this implicit assumption that chairs and people are the same level of object and that they're equally likely on some level to be manipulated. And the reality is that people are the things that typically get animated. And so Storytelling Alice has a language that's designed around that. But the second piece was about designing for inspiration and looking at the roots of where kids can find story ideas. And so we used animations that really said, okay, well, why would a character behave this way? And showing real story examples in the tutorial, where tutorials in the past had been all about simplicity. We have to maintain the simplicity, but then we also have to put in this other piece that's, we're going to show you that this is actually fun and it's about storytelling. And so we have formal studies on that as well. My favorite of the metrics from that is we looked at the number of kids who will actually sneak extra time to keep programming when they don't have to. And for Storytelling Alice, that's about 51%, which we were pretty excited by. So I talked to Randy a couple times about this session, and he had one very specific request, which was that we take some time out to actually demo Alice 3, which is in development now. So I'm going to hand over to Dennis, who's going to do that.
So what Alice 3 is, essentially, you take Caitlin's dissertation and you combine it with the assets from the Sims game from Electronic Arts, and you allow people to easily transition to a professional programming language, in this case Java. And those are the biggest problems that we've sort of encountered. And so in this example, I'm going to give you a very abbreviated demo where I'm going to have a daughter who's going to try to ride her dad to get in shape. And so the first thing she's going to do is say, you need to get in shape. And we'll have the dad respond by doing a sit-up. Okay? And this is your very first program. Okay? And the hope is with the new version of Alice, you'll be able to focus on telling stories and really taking all the lessons learned from Caitlin's dissertation, but do it with this high quality content and have fun. So we have all the constructs of normal computer science. It's essentially line for line Java underneath. And we're just sort of evaluating it now. But now we'll just do a loop, and he'll do 3 sit-ups. And then maybe we'll have the dad think, I'm tired. And the daughter will, you know, here we go. Is that all you've got? We'll spell it right and everything. Okay. And then maybe we'll have him do 250 times. We'll have him do a whole bunch of push-ups. What we want to do is allow people to use conditionals. And so in this case, we'll have, let's say if the daughter is facing the dad, well, the dad show off a little. So he'll do a 1-arm push-up. Okay. But if she's not facing him, you'll have him slack off and start doing the push-ups from the knees. Okay? And so in this case, we have, you know, the original part. You need to get in shape. You can actually crank it and speed it up. Do 3 push-ups. I'm tired. Is that all you got? And then he'll start doing these one-handed push-ups, but if you turn her around, he'll start slacking off. And then, whoop. Okay. And there's a bunch of this. You can actually transition later into, you can then transition it into a Java program. You know, just load it up. And you can do things like, I've added in here her counting out with the number of the loop. And so I'll just show that really quickly. And this is just trying to address a whole bunch of problems. One, we want to open up computing to more people. And so we're taking the lessons learned from Caitlin's dissertation, but we also have gotten a lot of feedback from the field as far as everyone's learning these concepts and it's no problem, but then transitioning to a professional programming language, they have too many things at once. They're changing the UI, they're changing the IDE, they're changing the language, they have new syntax, the data's hidden. So we're just going to make them focus on this one thing, which is the program. So that's the demo. Okay, and so now I'm talking about Alice 3, and I'm giving you that whole thing. First of all, for those of you out there who think that that wasn't an insane demo, you're not with me. The idea that EA would turn over the assets to the, for those of you who don't know, The Sims is the highest selling PC game in history. And somehow Randy convinced EA to donate them to us. And I still, every now and then, don't believe it. But I think somehow in this is, I think somehow in here is the story of the power of making lemonade. And I think if Randy has shown, if anyone has shown recently, certainly Randy has shown in the last few years that if life hands you lemons, Randy will make lemonade. And so this story doesn't start with Alice at all. It actually starts with the ETC. And Randy was, along with Don Marinelli, he created this Entertainment Technology Center. And a lot of his students, in addition to going to Imagineering, were also going off to places like Electronic Arts. And what he wanted to do was, when he took a sabbatical, not only to strengthen the relationship with Electronic Arts, but to also better inform how to better inform the ETC, to better prepare students, he wanted to go there and learn more about the process. So I'm going to talk a little bit about his sabbatical at EA now. And what I'll do is I'll let Randy
what Steve didn't
describe
tell me was
his first days there.
Sabbatical at EA, I'd been there for 48 hours, and they loved the ETC. We were the best. We were the favorites. And then somebody else pulled me aside and said, oh, by the way, we're about to give $8 million to USC to build a program just like yours. We're hoping you can help them get it off the ground. And then Steve came along and said, they said, what? Oh, God. And to quote a famous man, I will fix this. And he did. Steve has been an incredible partner, and we have a great relationship, personal and professional, and he has certainly been point man on getting a gaming asset to help teach millions of kids. And you know, that's just incredible. But you know, it certainly would have been reasonable for me to leave 48 hours into that sabbatical, but it wouldn't have been the right thing to do. And when you do the right thing, good stuff has a way of happening.
And so the Steve he's referring to in that talk is someone you may recognize from, he actually introduced Randy in the last lecture, Steve Siebold, who was at the time in charge of academic relations for electronic arts. And in talking to Steve about this whole incident, you know, and preparing to give this talk, he absolutely agreed. You know, he said no one would have blamed Randy if he rolled. I mean, it totally would have been understandable, but he stayed. And he did exactly what Steve wanted him to do, which was to interview all these people at Electronic Arts, really understand the process, and then create this field guide for all academics. So inform basically all of your competition for the Entertainment Technology Center, because all these programs seem to be forming for people to use gaming to attract students into computer science. Go around, interview all these people, and develop this field guide for people in an academic language, you know, so people can understand. And he went ahead and did that, and produced this document. And along the way, he formed this really strong bond with Steve. And they got to talking about, you know, what are their common interests, and he talked to him about Alice and about Caitlin's results and everything, and they discovered that they both have this common interest in solving the gender gap in computer science. Caitlin was showing this earlier. You know, this top graph is the men, and the bottom graph is the women, and as she was pointing out, right, it's plummeting, and it's also just abysmal for the women, right? And so they both share this common interest in solving this problem. Randy showed him Alice. They're really interested in that whole thing. And Steve asked, how can we help? And he doesn't just ask, how can we help? He's like, kid in a candy store, how can we help? Like, anything you want. And The Sims is just this perfect match, right, for Alice, because along with being the highest selling PC franchise of all time, it's also the only one on this list, right, of all these different systems that attracts more females than males. And the animation set and the model set just really matches up really well from the lessons we learned from Caitlin's dissertation. And I really like this slide. This is a Gary Larson cartoon. And for those of you who know Randy, this incredibly crazy and overly ambitious spider is Randy. I've seen him actually try to hang heavy objects with solder, right? And when I talk about hanging it, not with a soldering iron, like using it as rope, right? As if by some magic, like just by sheer will, he can make its tensile strength go up. But this is also really Randy in that even though it seems impossible that he's going to be able to snare this child in this spider web, he's absolutely right. If we pull this off, we'll eat like kings. And somehow he did. And I think that how that happens is you need both sides of it, right? You need the compelling research result that convinces a company that, oh, this will actually work, right? But you also need somebody who shows up, finds out that you've donated, you've donated all this money to someone else to try and asked you to help them get it off the ground, right? To stick around and do this thing so that you can build up this, not just this friendship, but also this trust that, oh, we can trust this person with our billion-dollar franchise's assets. And for those of you who are somewhat suspect about Randy's, that he's still having fun even with this incredibly terrible set of cards he's been dealt, this is a trip Randy and Steve took scuba diving in December, so he's still rocking it out. And so we've just scratched the surface, I think, in this talk. What we've tried to do is give you a little flair of some of the things that Randy's been able to accomplish and just how he's done it. And I think that there's a couple of themes that sort of go throughout it. One of it is you're just constantly lowering the barrier to entry to things. And the other thing is that he's been able to open up all these new areas. He's shown this incredible ability to connect to whether it be the perceptual psychology field with Denny Profit, or connecting to the arts, or connecting to educators. He's just sort of always had this incredible ability to build these bridges to other fields. And so I thought I'd leave you with what I thought was a really appropriate...
There is our memories.
And, excuse me. And this is a, from the last lecture.
There is our memories, and there's a way to remember you every day as people walk this campus. So we've come up with an idea. You've done great things for this campus and for computer science and for the world. Certainly Alice will live on. But the one we're going to focus on right now is what you've done to connect computer science with the arts. It was remarkable, it was stunning, it's had enormous impact, and it will last, I dare say, forever. So to recognize that, we are going to do the following. And my good job. Oh, there we go. In order to affect this, we had to build a building. $100 million building, which will allow us to do the following. You'll note, by the way, to orient people, so the Purnell Center for the Arts is the home of the School of Drama. That modern-looking new thing, half of which has a green roof, is a new Gates Center for Computer Science. And we had long planned to connect these two physically, both to allow people to get down from the cut to lower campus, and you have to admit, it carries tremendous symbolic importance. Well, on behalf of the Board of Trustees of Carnegie Mellon, and on behalf of the entire university, I'm pleased to announce today that the bridge connecting these two will be known as the Randy Pausch Memorial Footbridge.
Anyways, so thank you. We would all like to thank everyone who organized this and all of you for coming and for indulging us in telling this story. And also, just as a final note, we'd like to thank Randy just for the incredible impact he's had on all of us and everything. And with that, I'd like to open it up to if anyone in the audience has any questions or comments or anything they'd like to share. And I'll sit down.